Welcome to this workshop. I'm Matteo Falsetta, the project coordinator of MobiSpaces and EU program manager for GFT. And today we will talk about our workshop with the end users. So thanks a lot, end users, for joining. And I hope that there's going to be also other people joining. I'm going to be sharing the screen. Do you guys see it?
Yes, we can see it.
Great, thanks. Okay, so this is our wonderful cover of the event, and there is the full title of today. You can also see a spoiler of our use cases for those of you who are not really familiar with MobiSpaces. This is basically the webinar agenda. So there's going to be a brief introduction from myself, and we will talk briefly about of the project, and then we will give the word to our use case leaders for their presentation of the demos and a Q&A session with the end user, all ready to gather some feedbacks. Then we will be having a discussion when we will be gathering all the further feedbacks in order to have a complete picture over our use cases and what the use cases adopters have to say. And we will finalize the event with the conclusion and next steps. So you'll see me again afterwards. There are some basic rules of the game. So everybody, every use case leader has 10 minutes for the presentation, and then more or less, and then we will have 5 minutes use cases demo and Q&A. Please raise your hand at any moment if you have any questions, because we will give you the floor as soon as possible, and at least we'll be able to have you and better organize the Q&A sessions. Also, the questions that will not be answered in here will find a later reply, let's say, offline, in case we cannot cover, we cannot live. And please also check out the Q&A box that you have already seen below for more information on the functioning of the webinar, and also the dynamics we'll be having. Also, please check out our website. You can scan it there, the QR code, and have direct access to MobiSpaces.eu. Some final remarks. Well, the event is recorded, and you'll be finding it on the website, where in the next 24 hours. You can also find the PowerPoint presentations of each speaker, and please subscribe to our newsletter to be updated. We are many already, and it's great, but there is always room for someone. So please join us. Also, there is a very interesting part that is for you. So participants can apply to become members of the external advisory board of MobiSpaces. This is crucial because you can provide us some strategic guidance for the development of our use cases. You can have the visibility on the website and across the project. So I think it's a great opportunity for both parties. Well, now going to the main point. The MobiSpaces vision is basically to develop a data governance platform that utilizes the outcomes of AI-based mobility analytics in order to optimize the complete data path, let's say. And this data governance platform, we aim it to be mobility aware and mobility optimized, we say. So there are some main aspects. The effectiveness of the data governance that is improved with respect to the SOTA, the carbon footprint optimization that we want to implement, the AI-based data operations, and of course taking care of the safety, secure, compliant, and privacy respectful. And as of the main features, of course, the sharing and interoperability part is crucial for the data sharing, and we say like from cloud to edge to IoT, because there is a very interesting technology pipeline to take into consideration. We have 5, we say, exciting use cases. So you'll be getting to know them more. We have predictive maintenance from AMT. We have intelligent infrastructure traffic sensing from Bosch, edge-powered vessel tracking from Marine Traffic Kepler, edge computing on moving vessels from Frequentis, and enhancing nautical map from the geodata GST. Now, in this figure, you can basically find what are the main outputs of our project, which are the AI-based data operations toolbox and the edge analytics suite. So these are the two main enablers of our main technical objectives that you can find on the left. So having a data governance platform for trustworthy and reusable data operations, green AI enhanced data management, end-to-end declarative analytics, and high-performance batch and real-time analytics, together with explainable AI, federated learning over mobility datasets. And this is also cross-covered by the mobility data space and green and environmental dimensioning workbench. As the main results that we can share for now is the correct and timely, let's say, submission of all deliverables so far, which consists of the 43%. And for the time being, we have reached half of the milestones on time, and we have developed more than 10 demos that are showing that there are functioning components, and there is great outcomes from the work that we have been performing. Plus, in terms of dissemination, we have more than 350 subscribers to the newsletter. That's why we are a very big family. And we have published 11 publications, actually. So I leave the floor to Lorenzo Mantero and AMT. Please enjoy the webinar and do not hesitate to contact us. Thank you for the attention and see you later. Enjoy the workshop.
Okay, thank you, Matteo. Thank you, Diego, and good morning. Now I will share my screen. Okay, I hope you can see our task screen. It's Lorenzo Mantero from AMT, as Matteo said. We are the public transport company of the city of Genova, Italy, and we are here to present the work we are doing in MobiSpaces. Actually, we are something like an end user of this use case, even if we are the leaders, because the results of the use case will impact directly on our service and on the public transport of our city. So we are very glad about participating and about the results reached until now. As I was saying, we are based in Italy, in the city of Genova, and our use case, our work in the project is mainly about electric buses. AMT is buying more and more electric buses, and this changes a bit this changes a lot, I would say, the the management of a bus fleet. So if the bus are electric, they have to be managed in another way. Then I will show the main problems that affect and the main issues that affect a public transport electric fleet. And so we were searching for help in a better management of our fleet. We have some data sets. We have many data sets that, as many public transport companies, are stored somewhere without a good usage. And we would like to get better, to have better results in data analysis, in the scheduling of our fleet, and also in something specific of electric buses, that is the prediction on battery levels and on malfunctions, the main malfunctions that electric buses can have during their service. So the number of electric buses is increasing all over Europe. It's not only a problem of our city, Genova. Last year we had plus 39% of registrations in Europe versus 2022. And the main problem about electric buses is the duration of the battery, in a double sense, because a question can be how many kilometers can an electric bus travel during the day. But also there is another problem, that is after how many years the battery will decay, and the performance of the battery and of the bus will be reduced. But there are always old problems, because electric buses are buses, and so they face some issues that all kinds of buses face, like traffic, delays, malfunctions. So what the questions that we asked to ourselves are: how can we analyze better our data? How can we use the big amount of data to solve both the old problems and adding the new problems of electric buses? The answer is obviously that good data exploitation and usage can solve all the problems that our company have in managing a bus fleet. But we needed the presence of data sets and a good data usage and exploitation. As I was saying, it's not a problem of a public transport company to have data sets. We have many data sets. The problem is how to use them. We didn't use them well, but thanks to MobiSpaces, we are starting to use our data sets and make something good thanks to the good usage of our data sets. So the first result that we want to underline of the work done by MobiSpaces is a good data set organization. So a public transport company is not a company based on data that deals with data organization and data usage, data analysis every day. But thanks to MobiSpaces, we were forced to trust more on data and to organize them better, to make them available by partners, and to make them available for all the analysis that had to be done. So we organized our data sets, and we wrote a document about them to make them available and explainable to all the consortium. Then we defined a good architecture for ensuring the correct data path and data flow for the usage of our data. And finally, we started to have the first practical results for solving the problems I was talking about before. So the first problem that we faced was the optimization of the fleet allocation. So which bus to put on which line, on which departure, on which trip, to ensure the optimal usage of our fleet. So it was the first step to go to solve all the new problems I was talking about before. To do so, This optimization problem was solved thanks to our technical partner, that is engineering. And they built an algorithm, a genetic algorithm to solve this problem. I will show you a video that shows a bit the functioning of the algorithm, or as I was saying, we are the final user. So how the final user sees this algorithm working. So the algorithm, first of all, is trained with data sets that come from ourselves, from AMT, that regard trips duration. So every trip is registered, every bus trip is registered in AMT servers, and its duration is registered. And the model is trained with that. And it's trained also learning how the service work, which are the requirements that the public transport service of AMT has. So the model learns how much time takes a bus to get from a stop to another one in the different periods of the year. And the model so is able to understand how much time the bus takes to take the trip in a certain period of the trip of the year. So the first passage that an end user like AMT, like our company, has to do is to select a date on which we want to perform this fleet allocation. After selecting a date, the model, a genetic algorithm, tries to find the best solution possible for that date with the constraints that were made before. What is printed here is the fitness function that shows how increasing the number of iterations of the model, the solution is more and more optimal. What is needed to say is that in this case, as I was showing, as the video showed before, the time was running fast, but it's not so short. So the time needed to perform this algorithm is not so short. And so in this case, we put only 2000 epochs in this case to make the work shorter, but actually to reach better results, we should make this time longer. And this is possible because the scheduling problem is not a real-time problem. It's something you do sometimes during the year. And so you can also spend more times to find a better result. And then the final result of an optimization problem like this, in this case, is a file, is a matrix that shows, but this ends, so I will show you in the presentation in this other way. The matrix has some rows, some columns. It has m rows that correspond to the number of the trips that are scheduled for a bus line in that day, and columns that correspond to the number of the buses available that day. And so where there are ones, it indicates that the M trip is taken by the N bus. So it's simple thing like this, a matrix like this, but it can really be helpful to understand exactly, I show it, exactly and in an optimal way how to allocate our fleet. What we want to do now, because now the model is on, it is working as I shown before, but we have to add more constraints and more functionalities. So the most interesting part, as I said at the beginning, that we want to add is the one regarding batteries of electric buses. So the allocation of the fleet now is made only seeing how much time the bus takes from going to the first stop to the last stop. But it is possible to combine this data with teach to the algorithm, to the model, the behavior of the battery on that path. And so it would be a very good point to find, to take into consideration how the battery is going during the path. And so to be sure that buses cannot end their batteries during the service. This is what we will do. We are only at the half of the project, so this is what we expect and we will do in the next months. So thank you for your attention. I think I leave the floor to Bosch.
Yes, Gabriel, you're free to go.
Thank you, Diego.
For the audience, if you have question at the end of each presentation, you can raise your hand.
Right.
And,
yeah.
So if you have question for Lorenzo, raise your hand. So I don't see any question. So you can go, Gabriel.
Okay, thank you, Diego. Okay, so my name is Gabriel Braun. I will be presenting you the Smart Sense use case, which is all about traffic management and air quality. So just within this week, the EU has agreed to halve the limit values of air quality, so gaseous and particulate emissions, by 2030. So that shows that air quality is still a very hot topic. So a lot of urban areas are still exceeding air quality limits as of today. And as mentioned, by 2030, the limits will be halved. So there's a lot of problems to be expected by crossing limits. But this is also sensible because the current bad air, especially in urban areas, affects health quite a lot. So for this,
sorry, Gabriel. We still see the first slide. I don't know if you are turning your slide or not, but we see task 6.3. Just the very first slide.
Then let me try to reshare again.
Otherwise, I can share it for you.
Can you see now the second slide?
We still see the
completely black screen.
Yeah, the
It's now being presented.
okay. So
then Diego, please go to the next slide. Thanks a lot. So can you go to slide 2, please?
this one?
No, it's just the very first slide. Okay, thank you. So basically, to address these problems, we have come up with a test area which is located in Tisel, which you can see on the left-hand side picture. So there you can see the total area of the city of Thessaloniki, and we have selected a test area with 4 by 3 kilometers, where we place air quality sensors, where we do calculate a model for traffic emissions, and where we calculate an air quality heat map, which shows at every point the representation of the air quality. Next slide, please. Okay, so basically about the first data is the air quality sensors. So we have deployed 9 air quality sensors within this test area of Thessaloniki. You can see some examples of the installed air quality sensors on the left-hand side. So there's 2 types of devices being installed. One, which is basically the right picture you can see on the bottom of the slide. It's a kind of considered as a master device, which has more functionality. And then we have a smaller device on the left-hand side picture, which is located also in some devices. So we have been able to integrate all this data into a dashboard, which I would love to show you right now in the demo, but due to screen sharing problems, I can just show you the screenshot on the right. So it's all available in a dashboard. Basically, you see the points and you see a color coding of the points in red and in yellow. So this color coding is directly indicating an air quality index. Is also listed in a table below this map view. But of course, also the different pollutants like PM2.5 and PM10, also nitrogen, oxygen, and ozone can be viewed in bar graphs. So all this data is being recorded hourly because that's typically the standard which you rely on for air quality. So short duration has too much fluctuations, so you cannot derive any insights, and longer duration, it's like this, that the especially in urban areas, the air quality is fluctuating quite a bit over the day. All right, so this was the first type of data. What we also do is basically, especially in urban areas, the major source of pollution is the traffic. We do model the traffic emissions in this area. So for this, we need different types of data. We need the traffic counts on the vehicle. So how many vehicles on a specific points are passing by hour. But we also need some information from the speeds of, so how fast are the cars going or the trucks. And of course, we need the vehicle categories. So are this electric buses? Are this heavy-duty trucks? Is it electrical passenger cars? Is it diesel cars? Is it gasoline cars? This, of course, also impacts the emissions which are being produced. So all this is taken together and combined in a model, which is being deployed. And by this, we can, for every road segment, calculate the hourly emission rate. So this is the second type of data set we are producing. So here you can see some preliminary results. So this is a heat map already produced with MobiSpaces technology. So the visual analytics component of the MobiSpaces platform has been used to visualize this graph, which shows the heat map on a road in this test area. So we have been generated a consistent data set for a historic time period. And the next steps, we will do a gap filling because we have some data gaps. Also, we will use MobiSpaces technology for this. And we will develop different traffic management scenarios to improve the emissions of the cars and to gain a better air quality within this area. Okay, then please go to the next slide. So we then hope to see this in an air quality heat map. So here's the process how we generate the air quality heat maps. So basically, we need the weather which is present in the current hour. And we have been pre-calculating 2,600 or nearly 2,700 concentration fields, which basically show a normalized air quality, which is then being selected the right one for the current weather situation. We, in a next step, then are adding the modeled traffic emissions and some consideration of the air quality. And then we do a data fusion process with the measurements of our sensors, which are 9 in the area of Thessaloniki. And then we can generate a representative heat map of the air quality in this area, which can be then queried by an API. So this is the third data set we are producing. Can you please go to the next slide? So here's some example of a good and a bad situation. On the left-hand side, you can see in the color coding, there is overall quite good air quality. This comes from good dispersion by a high wind. But still on the roads and in the street canyons, you see there is some hotspots, especially in crossing areas. On the right-hand side, you can see here a picture. There is very low wind. Still, you can see the hotspots on the street, but as the dispersion is very bad, the bad air stays in the area, and yeah, it spreads all over the area. So basically, our idea is to kind of, especially in the events where we have this bad air or something like inversion weather situations, also take traffic measures. So even reduce traffic, but this has not to be applied in all situations, like on the on the left-hand side, where when you have good dispersion, you don't need to pull this measure to improve the overall air quality. All right. Let me then summarize. Basically, we have defined 3 KPIs. So we want to reduce the emissions by 10%. So for this, we are in good shape. We have a base data set, and we will be going to calculate traffic scenarios and see then which scenario will show this 10% of improvement. Then we have another KPI which targets towards transparency of air quality in the area. So as we have already deployed the 9 sensors, we nearly reached this KPI. And the third KPI is basically that all these traffic interventions cannot be done without a traffic management company. So we want to gain an architecture or solution which can be easily used by traffic managers. And for this, we want to facilitate the solution for them. And there we are also in good shape. So we are in good discussions with the municipality of Thessaloniki and the traffic planners. Okay, so this concludes my presentation.
Thank you, Gabriel. And there are some questions from the audience. If there are, please raise your hands or write in the chat. So it doesn't seem so. So I think, Costantina, you can go.
Hello, everyone. I'm Costantina Barreta, and I will present to you developments of the empty tracker use case of MobiSpaces, and later my colleague Dimitris Vitoris will show a live demo. So, the objectives of this use case is first of all to develop a robust and accurate vessel tracker to perform multi-sensor, multi-object detection to track vessels and detect dark targets. Dark targets are vessels that cannot be identified using AIS. Then we need to combine the results at the regional level, providing data aggregations from edge devices, reducing costly data transfer to centralized infrastructure. So we're heavily using edge computing. The data that we're using in this use case is first of all AIS. As you know, Kepler owns the largest network of AIS terrestrial stations, gathering both dynamic messages and static messages. Dynamic messages include information about the navigational status of vessels, such as the position of vessels given time, the speed over ground, course over ground, heading, and so on. And static messages include static characteristics of vessels, such as name, type, dimensions, and so on. In the radio frequency data, what we get is basically coming from radar signals of vessels. So the attributes that we can get are again the GPS assisting time stopping, the signal power, the RSSI, from which we can derive with some processing the location of target detected in RF data. So how we use edge computing, we have put together an edge device with the following capabilities. So we have an antenna that detects nearby marine radar transmissions, and we can correlate detected incidents with AIS in real time to reveal dark vessels in the area. So we were using edge computing in order to gather and process all this information instead of sending all this data to the centralized server. The edge device that we have put together also includes a computational unit so that we are able to do all the in-situ processing that we need to do. And two of our edge devices are also GPU enabled so that we can also run machine learning tasks. This is a snapshot of the radio frequency results that we have achieved. Actually, we have the targets detected in RF overlaid by AIS data. You will see more things later in the demo. And this is the whole workflow that we have in this use case. So we have two edge devices, each one including a pair of AIS data receiver and RF data receiver. So for each different data stream, we have a processing chain that is executed on edge. So for the AIS data, we need to do a number of processing steps in order to pre-process and decode the data. Then we use the data cleaning component of MobiSpaces in order to clean the data, remove noise. And then we use the FedBRF model that is one of the MobiSpaces technological outputs. So we use federated learning in order to be able to predict the next locations of vessels so that we can then synchronize in terms of time the two different streams. So we synchronize the AIS data stream with the RF data stream, and we are able then to fuse AIS data with RF data. So we perform position to track association. We associate the positions that are detected in RF data with the known tracks of AIS. And then we send this information to the server when we perform track-to-track association. So we identify the different trajectories that correspond to the different tracks that correspond to the same trajectories. So then we have the global track assignments consisting of position coming from both AIS and RF data. So we have these are the KPIs that we have in this use case. First of all, we need to perform data to object association accuracy more than 85%. We are very close to hitting this target. Data to track association accuracy and data to server flow reduction more than 30%. So as a next steps, we will continue with integration of the different components that we get from the MobiSpaces platform to the pipeline. We will continue with the evaluation, and then we will develop the next version of the MT tracker. Now I will give the floor to my colleague, Dimitris Vitoris, that will show a live demo of how we can acquire this data and processing on Edge.
Okay, give me a second to share my screen. Can you see my screen?
Yes.
Yes.
Okay. So here on the left on this window, you can see the system acquiring AIS data. This is done for two reasons. The first one is to give the system a situational awareness of the area, so it knows what targets are there that they are transmitting AIS. And also to give the system a value that is called RSSI. RSSI means Received Signal Strength Indicator. This is very valuable for us to calculate a distance to target. In order to make out a position of a potential target, you need two things. You need an angle relative to the receiver and also a distance. So the RSSI value is used to calculate the distance. Okay, so let me start the system. Now we are going to calculate to detect RF transmissions and not AIS is also an RF transmission, of course, but we are going to detect raw VHF transmissions. The system will go through an initial calibration phase in order to calculate the phase noise of its antenna, and then it will start monitoring the spectrum. We're monitoring around 2.5 megahertz continuously, but right now we are focusing on two distinct channels, the AIS channels, in order to detect the actual transmissions and where they come from, the angle. Okay. So this is what the system thinks its transmission comes from. You can see the last recorded angle here. It is in real time. Of course, there is some latency because there is a lot of computation done in the background, but we can more clearly see what it is recorded here. This is a pseudo streaming process. Currently, the system is recording its detection event on a file, and it streams it there. This will change, of course. It will be a socket where the next part of the code will connect and ingest the data. We have also cleaned the data a lot, and we're recording only what it is meaningful. And that is the sensor type, the detection, the RF type, which is here, the stack ID, the GPS discipline timestamp here in Unix time, the recorded bearing, the angle of arrival, the frequency, and of course the RSSI. Okay, this is done live as we speak. Its lobe you can see here is a detection event. That's it from me.
Thank you, Dimitris. Do we have any questions?
If you have any question, please raise your hand or share it in the chat. We will be very happy to discuss with you or have an interactive discussion with you. No, I don't think so. So let's see. Yeah, Thomas, I think you can go share your screen and
Sorry, I shared my presentation but forgot to unmute myself. So let's try again. Okay, thank you very much. So my name is Thomas. I'm with Frequentis, and I have the opportunity today to present to you the MobiSpaces use case Vessel Edge that is dealing with edge computing on board of moving vessels. Obviously, this is not just my work. There's a lot of persons involved within Frequentis, AIT, and ULB to make this presentation possible today. And I want to thank especially Andreas Reisenbauer, who worked very late last night and very hard to make the demo at the end of this presentation possible. Now, Vessel Edge is about edge computing on board of moving vessels. But what do we mean in the context of this use case by edge computing? Well, what we mean is that we move data processing onto a moving vessel. To be more precise, we move data processing onto a moving vessel that would normally be done in a coastal control center. So the data processing that would normally be done within the coastal control center is moved to a moving vessel with the objective to improve the situational awareness of this control center. Now, how does this work? Well, to be a little bit more technical here, this works by processing AIS data that would normally be processed in the coastal control center on board a moving vessel that is already a little bit farther away from the coast. Now let's go into some details here. I mentioned AIS data already twice. And just in case you're not familiar with the term, AIS refers to the automatic identification system. It's a radio frequency system that is used today to track ships which are moving on the ocean or near coast. Technically, it's a transceiver that you mount on a ship, and this transceiver emits something like a beacon in regular time intervals that allows ships in the vicinity to receive this RF beacon and learn about ships in its area. It is also used by maritime authorities who put antenna sites on coastlines to receive this beacon RF signals from ships near the coast, to track them and to gain situational awareness of what is happening in their area of authority. And AIS is a system that is required for all large ships and passenger ships by law, so you have a very good chance to get a very good situational awareness by using the system. Now, obviously, there are some constraints to the system. For instance, if you're a maritime authority and have your antennas on the coastline, it might be very difficult to know what is happening far away from the coast in the open ocean. And this is indeed a problem because ships outside of the reach of coastal AIS antennas cannot be tracked by these antennas without further measures. And this is exactly what our use case tries to address. So the idea behind our use case is to have a special vessel, a vessel equipped with our Vessel Edge results that receives AIS beacon signals from ships that are very far out in the ocean, that are not near the coast, and relay these signals back to the coastal control center by this improving their situational awareness by giving them data on ships that are too far away to receive their RF beacons directly on the coast. Well, this is not as easy as it sounds because you cannot just take the AIS RF beacons and relay them back to the coast just as they are, because most ships, if they have a data link connection to the coast at all, if they have one, it is usually a very bandwidth constrained connection. So we have to apply technologies that we developed within the MobiSpaces project to make the transmission to the coast possible at all. In particular, this means that Vessel Edge uses trajectory compression to compress the huge amount of AIS data that is received by our Edge vessel, to compress it down to a size that can actually be transmitted to the coast, filtering out only the relevant data that needs to be relayed back to the maritime authorities. And secondly, we apply a federated learning model that analyzes the received AIS data already on the ship outside in the ocean, and detects anomalies and relays only the relevant data back to the maritime authorities. So this is the architecture that stands behind our approach. But let's take a bird's eye view first. Conceptually, what we did here is to implement an instance, or actually several instances, of what we call a MobiSpaces mobility data space. So you have on the right-hand side of the slide 2 columns. The right column with the ship, that is the mobility data space installed on the moving vessel that takes the AIS data of faraway vessels as input. And on the left-hand side, you have the column indicating the mobility data space instance installed in the control room, consuming the data produced by the moving data space and providing it to the officers in the control room. Technically, it's implemented as a distributed containerized system with 2 main modules. And the 2 main modules in both of the data spaces are the anomaly detection model, which is a federated learning client and server, and the trajectory compression model, which compresses the trajectories on the moving vessel before relaying them to the coast. And in the coastal implementation of the data space, reconstructing the original trajectory and providing the visualization with the appropriate tracking, rendering, recording abilities that are used by the maritime officers. Now let's have a look at anomaly detection. Anomaly detection is a machine learning model that means that it needs to be trained to know what is actually unexpected behavior by ships. And in the demonstration that I've prepared for you today, we have 3 hypothetically receiving stations indicated by the red stars on the map on the right-hand side that have been trained with more than a year of AIS data from the Danish maritime authorities. After having been trained, these edge devices, as we call them, use the machine learning model that they have acquired to, first of all, train their understanding of normal ship behavior further and relay according updates of this federated learning model to the Coastal Control Center. And secondly, to detect abnormal ship behavior and relay this data back to the maritime officers to warn them about unusual events. Now, this is a short demo prepared by my colleagues from AIT here. We have 3 hypothetical edge devices near the coast of Denmark. In this illustration and example, they're located near the coast, but they could or should actually be located on moving vessels. The range of each device is also indicated with a line of where each device can receive AIS data. Each of these edge devices receives the AIS data in its area and performs anomaly detection. And the detected anomalies of this 15 minutes of AIS data on the right-hand side are indicated with color-coded arrows. So we have red arrows for direction anomalies, that is ships moving in an unexpected direction. Speed anomalies in green indicating ships that are unusually slow or fast. And blue indicates position anomalies, that is ships observed in unexpected locations. We applied obviously our metrics to these models, or to the results produced by these models. And we found that the communication cost from the edge devices to the central command at the coast can be reduced from 23.4 gigabytes per day down to 3.2 gigabytes per day. That is just 14% of the original data volume needed. And the accuracy of our federated model is compared to the accuracy of the centralized model on this table on the left hand side of the slide. And you can see that the federated model is almost as accurate as the centralized model, which we assume to be the ground truth in our analysis. Now let's have a look at trajectory compression. Trajectory compression works by receiving AIS positions over a defined interval of time, and then analyzing all the positions gathered in this time interval to filter out only the, let's say, relevant positions that need to be transmitted to reconstruct a trajectory, limited by the bandwidth of the ship's communication system. Now, in an operational configuration that you would actually deploy on a vessel, we would collect about 30 seconds of AIS data to make sure that a maritime officer never has data that is older than 60 seconds. And the compression rate would actually be dynamically adapted to the available bandwidth between the ship and the coast. But what you can see on the right-hand side of this slide is an illustrational example with a much larger collection interval for illustrational purposes. So we collect AIS signals for 20 minutes in this example, and the resulting compressed trajectories are indicated by the colored lines in this example. Yeah, that was the software side of our use case. The hardware side is still being assembled in the lab. So what you can see here is experimental hardware in our lab. We have an AIS antenna, a commercial off-the-shelf AIS receiver connected to a small form factor PC that runs this distributed containerized data space that I showed to you in the architecture. Obviously only the vessel part, which is connected over a network. And in our case, it's just Ethernet with artificially constrained bandwidth to the second instance of the data space in the control room. Okay, so let's put everything together. In this small demo, I have labeled the steps of the processing for you with the numbers. So we start on the top right. In the demonstration, we have actually not an AIS antenna because it's in our lab. We just use live AIS data from AIS Hub and AISstream.io, which is community AIS data. Then we decode data and put it into the two modules, the federated learning client, which improves its anomaly detection model for transmission of model updates back to the control room instance, and detects anomalies in the AIS data that it has received. Obviously, this has to be trained by a large amount of AIS data before you can use it. Now, in the next step, we compress the trajectory. And in step 3, we transmit the compressed trajectory, the small updates of the federated learning model, and the detected anomalies back to the coastal instance of the mobility data space, where we decompress the trajectory, we reconstruct it, we update our federated learning model, and we hand over the detected anomalies and trajectories to the visualization for the coastal officer. And I can show you a very short demo of this visualization here. Just give me a second. I have just to find the right one here. Yeah. Now, this is the visualization that the coastal officer would actually see. Special thanks to Andreas Reisenbauer again, who made this possible late last night. And you can see this is exactly the same data that we have seen in the previous stages of our workflow, the same area near Gothenburg. You can see that we have this extended range of situational awareness that would not be possible without the edge devices located in these two areas. So this is all from my side. Thank you very much. I will just switch back to the presentation, and I'm happy to answer any questions you might have.
Please don't hesitate to ask your question, to raise your hands, write in the chat if you have questions. Okay. I don't see any questions, so probably, Rita, you can go.
I believe that Niels needs to do also a presentation before, and then we can all do the interactive session together. So Niels, if you would like also to share your screen, then we can also
Yes.
hear from you. Perfect.
Yes, and I hope you can still hear me. I just got two
Yes,
low battery
yes,
warnings,
very
and
loud.
I think I was supposed to go on number 4, so let's see if
Yeah,
the battery will die midway.
Yeah, indeed.
So let's see if I can share my screen and go into presentation mode here. So is everything correct?
Yes, perfect. Thank you, Niels.
Okay. Thank you very much. My name is Nils. I work for GST, and we navigate the murky waters and vanquish sea monsters. That's what we do. And this is to ensure safe passage for all mariners. You see, back in the day, if you had some dangerous area, you would draw a little sea dragon to ensure that people wouldn't sail into this area. And of course, well, with all the modern technology we have today, do we still have sea monsters? And I would kind of argue that we do. What you're seeing here is the Danish DEF model. It's all the data that we have in the Danish exclusive economic zone. And all the yellow part is the interpolated areas. So we don't really have full coverage. And we are quite unsure that you see in the North Sea, especially, there's quite a few kilometers between depth measurements. Of course, this is not a huge problem, but it would be very nice to know, especially considering all the activities that are happening on the sea. And also, we're building windmill farms. We're building all these different kind of infrastructure at the sea now. So if you look closely at the map, you'll see these little dimples in the blue, and you'll have some white spots. And if we look a little closer at this, yeah, this is where the sea monster is hiding. This is the interpolation artifacts, so to speak. So Denmark has about 7,000 kilometers of coastline. It's actually quite a huge area. And with our current capacity, we estimate that it will take about 100 years to have everything surveyed with full coverage. And this can be sort of a problem because Denmark is one of the most heavily trafficked areas when it comes to marine traffic. We sit at the entrance of the Baltics, so everybody who wants to go in and out of the Baltic Sea will have to pass through Denmark. And this is a year's worth of AIS data, and you can sort of see the lines where they sort of turn this bluish purple. We have a high amount of traffic. And this, of course, makes this essential that we have good and accurate charts, that they're up to date. And of course, when we have all this traffic, the likelihood of accidents also increases just by the sheer volume. Let's go back here again, because the thing is, as Thomas and Constantina explained about the AIS data, so I assume you all know what it is now, is that it doesn't actually relay depth data, or what we call bathymetry. So what this use case is about is to gather crowdsource, if you will, bathymetry. And bathymetry is just a fancy word for depth data. So as it is now, this data is on a separate system. It's on the echo sounder. Most ships has one, but the data is not recorded. So we thought, what if we could record this data? And we could evaluate using edge computing and AI or machine learning, and then transmit this data via 4G, or if it's super important, maybe even have the federated learning system transmit it via satellite. So you get very critical updates immediately. So why is this so important to do? Well, the seafloor has a tendency to change over time. So if you imagine a wandering sand dune, like the wind will push the sand away and it will move over time. And you see this in the Sahara Desert. Of course, this also happens in the sea with waves. So there's a lot of things happening in the ocean all the time. And we have to be aware of this. Also, harbors are excavated, ships are lost, and if you have a mast sticking up, this can be a very, very big hazard. So we really need to know a lot more than we do. Also, much of the data I showed you on the very first image, the more than 1,000 data sets, a lot of this data also dates back to the early 1900s. So we have more than 1,000 data sets, but that's only counting all of the data that we've done in the last 150 years. So this idea of collecting data can also help us get a better understanding of where we need to resurvey. So what we want to do is we want to utilize CSP data for detecting discrepancies in our existing depth model. We want to verify our depth model, and we want to identify areas of low trustworthiness. And this is sort of a diagram that shows how this is done. So all the echo sounders and the AIS data, or the GPS data. Can you? By the way, can you still hear me? I got a second battery low warning.
Yeah, we can hear you, Niels. Yeah.
Okay. I'll try and finish. And hopefully you will still be able to hear me by the end. So we imagine something where we will have a federated learning system that's used on the edge to collect both the GPS and the echo sounder data, and then evaluate it on board the ship before pushing the new updated model. And I have sort of a data pipeline here that's also connected to the MobiSpaces data space. And this is some of what we imagine will happen here. So we'll get the echo sounder and the GNS data in. We'll do the edge computing, and then of course we have a subsection of our provider, the people who are in charge of the hardware before it reaches the GST infrastructure. And this is where we will incorporate the federated learning model. And of course, we will have privacy-aware visual analytics. You must remember that these people are staying aboard these ships, so it's also their home. So there could be privacy concerns involving AIS data. So let's just try and explain federated learning in a down-to-earth way. So we will train a model on AIS and the depth data. This model will then, in step 2, be pushed out to various different ships. They will update and train the model locally with their input, and then this is all collected in the end. So you get an aggregate model that contains all of this data. And the really good thing about this is that this is quite privacy aware. So you won't really have any true precision in this way. In the sense that you're broadcasting it in real time. So we need some training data for this to be able to work. And of course, we would really like to have some CSP data, but that's the whole point. We want to collect CSP data, and we don't have any. So we had to get a little creative. So firstly, we took the AIS data. You already saw that. That's a very used data set. And then we took our 50-meter depth model. So this is a 50 by 50 meter grid, and you sort of get one depth in this. Then we added a little noise. And of course, we also added some errors in this training data. So we came up with some errors that seemed likely, bubbles, glitches, and fish. So you imagine an echo sounder, if it hits a fish before, or a bubble before it hits the bottom, you'll get a very low depth. Sometimes you can even have the sound wave bouncing off the hull of the ship and then back to the sea floor and then up again. So you'll have sort of a double bottom at about twice the depth. And then of course we have the rocks. Now the rocks are, we could call them containers because the rocks, we sized them to the size of about a 20-foot container. And this kind of made international news because just before Christmas, there was a big storm called Pia here in Denmark. And there was a mass container ship, and it lost, I think, 16 containers, and they're still looking for them. So if our system would be able to detect one of these containers, it would be a huge benefit for both for maritime safety, but also for increasing safety and also for the cleanup effort. So this could be a really big deal. If you take a look at how the data is now fused, you'll see there's about a 1 in 200 chance of encountering an error, and sometimes these are clustered together. So the black is how the seafloor could be, number of data points, and then the depth in meters. And then, of course, all the little errors that the system, the federated learning system, will have to figure out how to filter out and classify correctly. So this is what it looks like from above in 2D space. And so this is the first early experimental results from the Austrian Institute of Technology. And the thing that really is striking is that you have a 0.991% accuracy, and that looks very, very promising. It looks very, very good. But the thing is, with federated learning, it's a bit like saying that speed is the only metric for a good voyage. So like, how fast can you get there? And then forgetting about detecting icebergs or whatnot. So the closer metrics for this is recall and precision. There are much better metrics for how well your model is really doing. Again, accuracy is a bit like saying, okay, yeah, this is an error, this is an error, this is an error. And if you guessed everything that is an error, you'll get a 99%. But it doesn't really tell you if it's classified correctly. So we want to find the iceberg because we all know how the story ended when we didn't consider that. So where are we so far? Well, last year we tested the box. That's the MMS proxy thing you see there on the wooden board. That's the box. So we have the hardware up and running. We had the first prototype of the machine learning model, and we provided some data for them to, like, simulated data for them to test it. And so the next year here is all about the sea trial. We're going to have a second sea trial. The purpose being to retest the equipment, but also to integrate these two. So the hardware and the software, in this case, the federated learning model, they will have to run on the edge device, and we will try to bring these two together. And hopefully this will also mean that we can integrate a little bit better with the MobiSpaces platform and really harness the technologies that have been developed here. So yeah, this is it for me. There should have been a thank you here. Ah, must have deleted that. Yeah.
If you have any question, again, raise your hand, write in the chat. You are very, very welcome.
In the meantime, okay, we can also start moving to the last part of our workshop. and we hope that you still have a lot of energy also to interact with us a little bit. So I have just pasted in the chat a link, and I please all of you to access it. In the meantime, I will also start to share my screen so that we can all let's say, work together on this last part. And okay, let's see. I suppose that you can see a question in front of you. Okay, that is actually one of the questions I would like to ask you. And in order to do so, what you have to do is actually to either use the link that I have just pasted in the chat, or go to menti.com and then use the code 88273547. So the number that you see here at the very top of this slide. And then you can you should also be able to start typing also your let's say some questions. I'm not sure if you ever used this tool before. It is pretty easy. So yeah, you just need to follow the what I just mentioned. So go to the website and then use the code. So okay, I see that a person said that he or she works in a public transport, is a public transport operator. Do we have any other people that work in the same area, or for example in technology areas like, I don't know, for example, Edge, AI, IoT as well? It would be nice, I mean, to hear more about your background. Okay, I see that in the meantime, another person said that works at trade analytics, so a little bit more technical work, I have to say. Digital communication, then okay, then we have also people that have experience in telemetry for logistics or public transport analytics, which, I mean, it is very nice to hear because it is actually also what MobiSpaces is doing. So yeah, we see that we have some connection, also vector tracking, perfect. And any other inputs? We still have a couple of minutes. Okay. Okay, so more or less, I have to say that people that are with us today have some background that is very similar also to the use cases of MobiSpaces. Oh, nice. Now here we have also 5G, perfect. Then other people are working in software engineering, smart infrastructure, and also AI, which is nice. As you might have also noticed at the very beginning, when Matteo, our coordinator, was also making this presentation. After this workshop, we would like also to organize a series of co-creation workshops. Then we will also give you a little bit more information later on. But it is very nice to hear that you have different backgrounds, because if you're interested, then we can also involve, and we might also potentially learn from each other and improve our work. Now, if it is not a problem for everyone, I will move to the next slide. So then I can also ask you our second question. So, I mean, here we would like just to understand a little bit what are the primary objectives of your company. So, for example, I mean, just to understand again, if, for example, you are doing something similar or complementary to what MobiSpaces is doing. So feel free again to write here. You do not have any limitation in space as well. So you can also write very long texts, and so that we can also, or be very short, obviously, so that we can understand a little bit better, again, if we have any connection. I see in the meantime that someone also writes something in the chat. Oh, okay, no, it was actually Diego that was also asking you to share your inputs. Okay, I also understand that for replying this question, you might also need a little bit more time. But please feel free also to share your insight with us. Okay, so we have the first comment about, let's say, what one of the attendees says that one of the main aims is to strengthen green mobility. Okay, so I believe that in this case, by green mobility, we mentioned, let's say, both transport, land, and let's say maritime transportation, I believe. Any other suggestions from anyone? For example, in the first question, we were also mentioning that some people are also working in, for example, 5G, AI technologies, etc. So if you would like also to share some insights here, we would be very pleased. I will just wait another couple of minutes and then I will move to the next slide then. Okay. The next question is a little bit more interactive. We hope that you will like it, by the way. Okay. We do not have any other input, so then I would feel that more or less, I mean, the objectives will be, oh, nice, thank you. Also for sending another input. So here we have sustainable, ethical use of AI-based systems. Nice. Actually, the ethical AI is always a very, if I may use also this term, it's a controversial, because obviously, I mean, the AI offers a lot of potentials, but then it is not always very easy to also to protect data, especially when we are dealing with sensitive ones. But in the case of transportation, we do not always deal with very sensitive data, but I mean, it is always nice, I mean, to also deal with this topic. So we might also get in contact with this person for any other workshops. So if it is fine for everyone, I will move then to the next slide. Oh, okay, no, we actually got another input. So BAI, I hope that I'm pronouncing the name of this company correctly, is a solution for optimization of multimodal logistic carbon footprint. Nice, okay. So it is always strongly related also to the transport environment. And then another company is, let's say, focus on creating a link between innovation and daily operation. So nice, okay. Okay, so more or less, I mean, again, we had the confirmation that you work on fields that are very similar to the MobiSpaces environment. Now, I will move to the next slide, and I thank you as of now for also sharing your input with us. And this one is a little bit more interactive. So in front of your screen of your, let's say, cell phone, according to what you are using to reply this question, you will see that you have like 3 different options that are related to, in our opinion, the most impactful challenges that our use cases are facing when they are developing, let's say, their models or architecture. And we would like to understand from you what, in your opinion, is the most impactful one and what is the less impactful instead. What you have to do is that you will see that you have like drop options. So you have just, I mean, to move the option and give them, let's say, like an order. Okay, and then you have to press submit. Okay. So it seems that as of now, the most impact, okay, no, we actually have 2 at the same place. So that you're really facing integration challenges that hinder it. No, okay, we still have some changes. I will comment the results then in a couple of minutes. I will still give you a little bit of time to comment them. Okay, I believe that we have a, let's say, winning, let's say, challenge. So it seems that the main problem is related to the integration that, let's say, related to real data processing and system compatibility, sorry, which, I mean, was also something that, for example, Niels was also mentioning at the very end. Like, I mean, or also other use cases, like, for example, very often we are either lacking data, but very often they are not always available in cloud, they are stored somewhere else. So then in general, I mean, it is some of the most challenging aspects, which, I mean, I would also agree here. Then at the second place, we had the limited integration of environmental factors in transport planning. Yeah, also because I have to say that you might also face some challenges from time to time also to evaluate the environmental factors. We have too many, and even, I mean, from a local point of view, it is not always easy to track them in the same way. And then we have also challenges in resource allocation. I would say that in this case, the resources are related both from, let's say, an economic, but also a personal point of view. So thanks again, everyone, really for sharing your insights. And we also know that actually it wasn't easy also to find 3 challenges. So in case you believe that we missed something or some challenges, we would like really to hear from you and understand what, in your opinion, would, let's say, still represent a problem in developing use cases in the transport areas, by also exploiting data spaces and technologies. Your insights will actually be very helpful for us, because it will also help us understand a little bit if we did not consider something in the development. So feel free also to be creative here and let us know, I mean, if we should consider something more. Then also something that I wanted to mention is that at the very end of this part, there are still a couple of questions, not too many. You can also explain a little bit, for example, something. So feel free also to raise your hand. And if you would like also to interact with us, ask some questions like you have plenty of time and space for this. Okay, I will still wait a couple of minutes and see if you have thought of any other challenges. If not, then it means that we're going in the right direction, which is also nice. Okay. Maybe I will wait another minute and then I will move to the next question. Okay. It says that actually we have identified already the most impactful challenges. So, okay, we're happy to hear that. And yeah, here actually I will maybe spend a little bit more time here, because okay, today, I mean, we have heard of 5 different use cases, 5 different, say, practical examples of how it might be possible, for example, to evaluate the environmental factors in developing, for example, transport system in European cities. And our use cases leaders have also came up with some ideas on how to overcome them, even though we are still in the middle of the development. If you have any other ideas, any other suggestions, especially, I mean, because we also notice that some of you are working or developing something similar. We also heard that before from the chat. We would like to understand that. And also, for example, you are developing something that is very similar to this, then please let us know. The ideas can come, I don't know, to improvements of data management, let's say, if you have any ideas of how you store the data, or I don't know, on how to also build your infrastructure, etc. Yeah, it would be nice to hear from you. I hope that. Oh, maybe something that I did not mention is that, okay, I am actually moving the slides, and what you have to do in case you do not see properly this question is that you should press next question or next slide according to the, let's say, if you're using it on mobile data or sorry, on mobile or on your laptop. Okay. Okay, this is that. Okay, anyway, maybe I will just wait another couple of minutes and then I will move to the next slide. By the way, all these inputs will be also be used to build our next co-creation workshops. So in case, for example, you didn't think of any new ideas, we might still, let's say, use additional workshops also to gather some insights from the attendees. I will maybe move to the next slide. Okay. That are actually related to limitations or constraints of your current solutions. Here again, feel free to share your insights. So please also, in case you cannot see this question on your laptop, press also next slide or, okay, I see that we have one input. Thank you for sharing that. So the first one is that we're lacking standardization. Yeah, very often, I mean, we do not have enough standards or semantic rules that are actually common to all. So, which is also partially related to the data harmonization, which is a crucial aspect for developing the use cases. Okay, and any other ideas, or do you all agree with the standardization issue, let's say? Okay, another one is lack of research towards decentralization and of multi-architecture open applications. Yeah, this is also quite crucial aspect, I have to say, especially because if I may, I believe that this problem is also related to the fact that we do not always also store data in the cloud or always in the same location. So then it might really represent an issue. Okay, what I feel actually from this discussion is that we have clear what are the challenges of developing the use cases, because also when we were trying to classify them or trying to understand what are the problems that we are facing, we had that clear idea. But when we came up with some additional solutions or ideas, it was a little bit more difficult to come up, I mean, with some feedback. So most probably it is really the area where we should focus the most. I mean, to maybe try to collaboratively think together of some solutions so that we can really overcome in the best way the problems and issues that we're facing now. So it was actually helpful to understand that. I will move to one of our last slides that is more related, I mean, on how we can help you also meet your requirements and preferences. So it is also really about the type of cooperation that we can achieve together. You have also here before the use case. Sorry, you have saw the presentations of the use cases. So how, for example, they are categorizing data, how they are starting to build a demo, and for example, also a federation model. Do you think that actually we can also share some of these best practices with you, so that it can also help your work? Okay, we got a very general reply, yes. Maybe if you can be also a little bit more specific here. If it was, for example, for example, something that might be interesting is also if we can share data together and see maybe we can also improve the quality and reliability thanks to this. Okay. I believe that the yes was related to this. I will just wait another couple of minutes and then I will ask you our final question. So then we can move forward. Then events like like this one are useful And then they also say that access to open APIs, datasets, ontologies, and demos. Yeah. Actually, what I wanted to say is that also related to this comment is that the demos are still under development, because we're actually at the almost half from the project development. But obviously, we can also share all the best practices demo to you, so that you can also use it as best practice for your daily job. Then we also have another reply, and a person is asking if it would be possible also to see the results of the use cases, to see which one is useful for your company specifically. Yeah, it would be possible. Actually, on the MobiSpaces website, you will see that we have some pages related to the use cases. As of now, we have included only, let's say, general information about the objectives, the technologies that they are using, and some impacts that they're contributing to. But our aim is that, let's say, shortly, also, let's say, after this workshop, we will also share with you some information, some of the preliminary results of the use cases development. And at the very end of this workshop, by the way, we will also develop a, let's say, booklet or a document where we will summarize the main inputs and work that has been developed by the use cases. So you can then find some information then both on the website on additional materials that we will develop. But in addition to this, then we can also have some calls together also with the use cases if you are interested, so that we might also understand a little bit better how we can help each other. So with this, I thank you again for sharing these inputs with us, and I will thank you. Actually, it was my last question. So I will stop sharing now, and I would like actually also to understand from the attendees if any of you would like also to share some feedback. Feel free also to raise your hand. We still have some time, so okay.
Yeah, especially the one who commented, I would say, in the last question. So it will be very nice to have a discussion, an open discussion, a little bit deeper than what the question allows. So you are very welcome to raise your hand and to speak.
Okay. While we're waiting, Diego, if I may, I would like also say to also, let's say, share the information that following this workshop, we will also organize others that are the co-creation workshops. So they will be a little bit more interactive. They will be actually closed workshops where we will invite specific experts, and they will also help the development of all the use cases from a technical point of view. So following this workshop, we will also start organizing them, and if any of you, especially the ones that also wanted to understand what are the results of the use cases and how they can also use them to for their job, then feel free to drop us a message so that we can also include you and invite you for the next workshops. If we do not have any other questions, then maybe Matteo, I will pass the floor to you for some closing remarks. Thank you.
Thanks a lot, Rita, and Diego for coordinating this workshop that has been very useful for us to gather some feedback from our end users, and also to gather some new participation and engagement for further developments at a project level. So we can't wait to see the next workshop, of course, that I guess it's going to be more technical driven also. So we expect to show you some technical results more in depth in the next one. And I really can't wait to show you some further proceedings of this project that is going pretty well so far. So we have noticed some key points that we will further analyze, and thanks for helping us moving forward. Okay, so I want to thank you all for the participation. Please subscribe to our newsletter if you need to recatch some main aspects or key points of today. Do not hesitate to get back to our website and see in our section the video uploaded. And never ever hesitate to get in touch with us. Okay, so thanks a lot and have a great day and proficient work.
Thank you. Bye bye.
Thank you, everyone. Bye bye.
Thank you.
Bye.
Bye, everyone.
Bye.